Hi students, very good morning to all of you. In today's class, we are going to discuss about the switching of phase windings. Switching of phase winding for the stepper motor. In the previous classes, we have discussed the different types of stepper motors, variable reluctance stepper motor, permanent magnet stepper motor, and also we discussed hybrid stepper motor. How to switching on the phase winding or the stepper motor. So in this class we are going to study how to switching the phase winding with the help of the power semiconductor switches. We are going to see. The today's title is the different configurations for switching the phase winding. The different configuration for switching the phase winding. So we have the different type of stepper motor. What is a stepper motor? The stepper motor means it is convert electrical pulses into the rotational movements or discrete steps. It is an electromechanical device. It is an electromechanical device. So basically, the stepper motors are classified into three types. One is variable reluctance stepper motor. The second one is permanent magnet stepper motor. And the third one is called as hybrid stepper motor. Here, the hybrid stepper motor means it is a combination of variable reluctance stepper motor and permanent magnet stepper motor. We'll see how we design hybrid stepper motor. See, what is stepper motor? The stepper motor already we mentioned. Stepper motor is electromechanical device which convert electrical pulses into rotational movements. Okay, first we identify types of stepper motor. So what is step angle? First one is electrical pulses into rotational movements or steps. So this is a stepper motor. So first next one is very important, step angle. Step angle is denoted as theta s. It is equal to 360 upon number of phases into number of rotor. So this is basic ideas. Next one, we have types of stepper motor. We have stepper motor. Second one is permanent magnet stepper motor. Third one is hybrid stepper motor. So we have three categories. So both are having stator and rotor. Here also we have stator and rotor. Here also we have stator and rotor. Okay, so these are three classifications. Now, this stator we have stepper motor, stator and both rotor made up of steel lamination. Steel laminations. Here stator is made up of steel lamination. But rotor is made up of permanent magnet materials. We have studied different types of permanent magnet materials, Alnico, SMCO, like that materials. Next one, hybrid stepper motor. As already stated, the hybrid stepper motor is a combination of variable inductance stepper motor and permanent magnet stepper motor. Here, stator is a steel lamination. Stator is a steel lamination. And the rotor is a combination of steel and permanent magnet. It is a combined PM and steel. Next one, what are the advantages? Step angle. The minimum step angle for the VR stepper motor is 1.8 degree. Permanent magnet, the step angle is limited about 30 degree to 60 degree. Hybrid stepper motor, very low step angle, that means very high step angle. The minimum step angle is 0.5 degree. So these are all the importance of the stepper motors. And the another one, today what we are going to study, how to switching the VR stepper motor, how to switching the permanent magnet stepper motor. How to switching of phase winding. So we have unipolar winding, bipolar winding, bifilar windings. We have different types of winding is there. We see one by one. So stepper motor, the stepper motor having concentric winding on the stator poles. These windings are connected in series, diametrically in opposite poles. See here, so this is your stator. Okay, so this is a phase A, that is phase A, this is winding. This is your winding. This is your winding. Here we have switch. We have switch here. This is A prime. This is a B and a B prime. So similarly you have winding here also. So these windings are connected in a series to form the phases. Okay, to form the phases. Okay, so these are the diametric opposite poles. These windings are connected in a series to form the phase winding. Okay, so we have what are the types of switching is there? Unipolar supply, bipolar supply, and bifilar binding. So these are basically three configuration is there to switching the phase windings. So next one we'll see Hutch bridge type connection with the unipolar supply. Hutch bridge connection with the unipolar supply. Okay, so here see here, this is your bridge type connection. For phase, in this case, for phase, 4 switches are utilized. 4 switches, the switches S1, S4, S3 and S2. Here we have winding, this is a phase winding. The one term of the phase winding is A. The another term of the phase winding is A prime. We discussed in the last slide. So one term of the winding is A. Another term of the winding is A prime. So this is indicate direction of current flow when switches is turned on. Respective switches are turned on. This is applied DC voltage. So in this case we need 4 switches for phase. 4 switches for phase. Okay, and another one, winding fully utilized, fully used. This is very, very important. Now, what is the condition? First condition. If you want to energize the phase A. So now switches. Now see switches. S1 and S2 is on position. S1 and S2 is on position. So these two are going to close. These two switches are going to close. Now the current flow is from positive terminal of the battery going in this way and switches S1 again A and A prime S2. So this is the direction of current flow. This is your direction of current flow. Now what happens? See. So what is the direction of current flow? S1 and S2 is on position. The current starting from positive DC, then S1, then A, then A prime, then S2, then minus this. This is the direction of current flow. Now what happened? So now what is the current? The current is flowing from A to A prime. A to A prime. Fully utilized means what? The current is continuously flow through the full winding. That is called fully utilized. Now these switches S1 and S2, S1 and S2 are turned off. What happens? See, the energy stored in the inductive winding is feedback to the supply side. Through diodes D3 and D4. Through diodes D3 and D4. So this is the first mode of operation. See second mode. Now switch S3 and S4 are turned on. Now what is the current position? The current is moving from A prime to A. A prime to A. Okay, A prime to, this is a current position, A prime to A. Okay, now see, where is S3? Here you have here S3. Your S3 is going to close. So S3 going to close. The current is flowing A prime to A. S4 is closed like that. It is a current direction. Now write the current direction. The current direction is positive DC and S3 and A prime A, next S4 and minus DC. This is current direction. Now these two switches S3 and S4 are turned off. What is condition now? This current, so this energy stored in the inductive winding is feedback to the supply through diodes D1 and D2. Where is the D1? So D1 is here, and D2 is here. Okay, so this is feedback current feedback to the supply through this diode D1 and D2. So this is for H-bridge type connection with unipolar supply. So unipolar supply means we need only one supply source. Most cases we are using for variable access stepper motor. So next one is bipolar configuration. So in this bipolar configuration, mostly used for permanent magnet and hybrid stepper motor. These two stepper motor bipolar configuration used. What is meant by bipolar? Bipolar means we have two sources, two batteries. In the previous case, we have only one battery. We have here only one battery source. So we have unipolar supply. We have two sources. DC sources. That is called unipolar. But another one here, the phase winding is grounded. The phase winding is grounded. Here also, winding is fully utilized. Here also, the winding is fully utilized. Okay, now see, and another one important thing is, here we reduce to 2 switches. The previous case we are using 4 switches, but in this case we are using only 2 switches. Okay, we have used S1 and S2 only, and also reduced diode also. So the main importantly, we reduce number of switches, so cost of the system also reduced for this switching circuit. So with the use of bipolar supply, the number of switches can be reduced to 2. We are using only 2 switches, and also we are using 2 diodes. Now see here, S1 is on, the current flows from A to A prime. S1 is on, where is S1 is on? This is going to turn on. S1 is going to turn on now. S1 is going to turn on. You are going for this way. Current is flowing this way and going to ground. Okay, so S1 is on, flow to A dash. When A to A prime, sorry, A to A prime, when it is off, S1 is off, the energy stored in inductive winding is feedback via D2 into the source DC2. Okay, so once S1 is turned off, this energy flowing through diode D2 and back to the source DC2. Okay, so this is one mode operation. The second mode is S2 is on. S2 is on. Okay, S2 is on means what? Where is S2? This is for S2. S2 is on. Now current is flows from A to A prime. A to A prime. When it is off, the energy stored in inductive winding is feedback to the source via diode D1 to the DC1. So this is a bipolar configuration. This is a bipolar configuration. So what are the important observation from this bipolar? We are using 2 sources and also reduced 2 switches. 2 switches from the 4 switches previously we studied. So this is for one. Here also winding is fully utilized, fully used. Here also winding is fully used. So this type of circuit mainly used for switching of permanent magnet stepper motor and hybrid stepper motor. Permanent magnet stepper motor and hybrid stepper motor. So next configuration is unipolar supply with the center tap windings. Unipolar supply with the center tap winding. So we are using only one source. See here, there is only one source. This is only one. That is unipolar supply. But we are using 2 switches. S1 and S1 is one switch and S2 is another switch. But what is important? Here winding is utilized half of the winding. So previous case we are using full winding used, but in this case we are using only half winding utilized, only A to this point. Because winding is a standard. The winding is standard. Okay. So in this case winding is half of the winding only utilized. Okay. So S1 is on. See here, S1 is on. S1 is going to close. S1 is going to close. The current flows from A to ground. Current flows from A to ground. So now S1 is closed. Now current is flowing from positive terminal to A to ground. This point. So this area only utilized. So this winding is not utilized. Though the S1 is turned on. Okay. Now if S1 is off, it is going to turn off. The current is previous through diode D1. So the energy stored in the inductor, half of the inductor, energy stored in the winding, half of the winding is freewheeling through these diodes. Freewheeling means circulating. Freewheeling means circulating. What is the next? If S2 is on, condition next. It is already freewheeling current. Once freewheeling current is over, S2 is going to turn on. S2 is going to turn on. S2 is going to turn on. What happens? See, the another half of the winding utilized. This portion is utilized. Now also we are going like this. Now also going to like this. The half of the winding utilized. So now current flows to A prime to ground. So now S2 is off. S2 is off. The energy stored in the inductance or inductive windings is previous through diode D2. Diode D2. So this process is continuous for the operations. Next one is use Biflow binding. Biflow binding, this is a Biflow binding structure. This is a Biflow binding structure. Now, in this case also we are using only one source, voltage source. The source is grounded. Here also we have center tap. Here also center of this binding, phase winding is grounded. So we have two terminals. The one terminal is A, another terminal is A prime. Okay. See, some of the textbook is given like that, A1, A2, but in initial state intervals we are using A and A prime, so that you can use A and A prime. Okay. Now, when S1 is closed, S1, where is S1? S1 here. S1 is closed. S1 is closed. A MMF is created by binding A. Where is binding? Here. This is binding. The MMF is created, the binding A. When S1 is opened, the receding MMF will induce in the current A prime. When see here, very important. When switch is closed, the MMF created the binding A. When switch is off, the receding winding is passing through the A prime. A prime. So A prime, that is means which draw the out to the power supply via D2. So this current will flow like this to the power supply to main power supply. Okay, no? So this is one direction. This is one method of treatment. Next step, S2 is on. S2 is on. This is going to close. Similarly, MMF is induced the A prime. MMF is induced the A prime, which is going S2 going to turn off. What happens? See, so this receding MMF will flow in this A. So now S2 is open. That means S2 is open means the current receding. Now this will follow this right path. So the current will move to the supply through the diode D1. This is for bipolar binding. So next one is summary of this class is. So in this class we are studying switching off phase winding, switching off phase winding. Okay. First we studied Hutch bridge configurations. So in this Hutch bridge configuration, 4 switches are used and the binding is fully used. 4 switches per phase. That is very important. 4 switches per phase. This is one. Next one is bipolar supply configuration. Bipolar supply configuration. So this is used for permanent magnet stepper motor and a hybrid stepper motor. Hybrid stepper motor. Hybrid stepper motor. So we have used two sources, two voltage sources. The two voltage sources we are using only two switches. We are using only two switches. So two switches. So in this case also the winding is fully used. Okay. Next we also study bifilar binding. Bifilar binding method. So these are the switching phase rating of stepper motor. Okay. So in the next class we are going to discuss about characteristics of stepper motor, and also we discuss small numerical problems related to the stepper motor, how to find the step angle from the given data, resolution of the stepper motor also we find out. Thank you.